All right, well, welcome back. We are going to be on section 4.5b today, more on U substitution. So I do have a few homework questions worked out for you. These are some questions I got last year. So if you'd like to see these worked out, just pause the screen and you can look at the full solutions here. So I have number 15 from your pattern recognition worksheet. I have number 19. And I also have number 23. So if you'd like to see any of those worked out, just rewind and pause the video where you'd like to see the solutions. Okay, so we are going to do a bit of review before we start section 4.5b. So the first thing I'd like for you to do is take a look at all of these different symbols. And maybe let's first just focus on this one here. I have the integral of sine of x dx. So what does this really mean? Well, remember we talked about that the integral symbol, that elongated s, combined with that differential du, actually tells us, so this symbol combined with this symbol, it's kind of the capital letter and the period at the end of the sentence. Kind of like in English, we need both to make a sentence. So combined, they tell you to find all antiderivatives of the stuff in between. So this here means find all antiderivatives of sine of x, where the variable we're working with is x. That's indicated here by the differential. So you can say that this means find all antiderivatives of sine of x with respect to x. All right, so one such antiderivative would be negative cosine of x, right? All antiderivatives would have this form, negative cosine of x plus c. So I now have the family of functions whose derivative would be sine of x, right? If I differentiate this expression here, I should get sine of x. All right, let's take a look at this guy. I have the integral of sine of u du. So remember, the integral symbol combined with du means find all antiderivatives of sine of u. So same idea, just this time we're using u instead of x. So the answer here would be negative cosine of u plus c. All right. All antiderivatives of sine of u. All right, in my last example, I have the integral of sine of y dy. Again, the integral, this elongated s, along with the dy, means find all antiderivatives of sine of y. So my solution here is negative cosine of y plus c. All right, so I just don't want you to freak out if you have a different letter other than x. Just remember that an integral along with a differential means find the antiderivative of everything in between. And notice in this case, we are dealing with all indefinite integrals. Okay. All right, so let's go ahead and start on section 4.5b. I'd like for you to pause the video, talk with someone around you from your pattern recognition worksheet from last time. Answer these questions for me. When determining which expression you should let u be, what are some things you look for? What kinds of things are bothersome or not bothersome? All right, so go ahead and pause, and then we'll regroup for discussion. All right, so hopefully you paused and talked with someone around you. So some things you may have talked about when you're looking for u You're also trying to see if some version of the derivative of u is in there, right? So that's one way that can be helpful when determining u. Some of the things I want you to remember are not bothersome are coefficients, right? If you have an extra coefficient, whether that's a pi or a 3 or just a -1, those kinds of things are not bothersome. If when you differentiate you get an extra variable that was not in your expression, then that could be bothersome, all right? But coefficients, we can deal with those very easily. All right, so let's take a look at some examples here. I would like for you to get 2 highlighters out, 2 different colors. So if you need to pause the video, go ahead and do that now. All right, so we are going to start these just like we started our examples from yesterday. And if it's helpful here, we can hide the second example for now and give us some space here. All right, so the first thing I want to do is identify u and du. All right, remember that u substitution is like anti-chain rule. All right, so if you notice here, you have some expression raised to a power, so kind of like a baby and the mom, right? So when you are going the other way around, when you're anti-differentiating, you want to let u typically be the baby, the inside function. All right, so remember again, this symbol, the integral symbol combined with the dx just means find all antiderivatives of all this stuff. Now the problem is this is a little bit more complicated than just sine of x, right? So what we're going to do is try to write this as a much simpler integral, and then find the antiderivative of that, and then we can substitute back in. All right, so let's first determine what u should be. You're getting good at this now, yeah? So u should be x squared plus 1, right? And what's nice, what you should notice here is that the derivative of this is present inside the integral, right? The derivative of x squared plus 1 is 2x. So du is going to be 2x. You can multiply that dx over. So du is 2x dx. All right, so what I'd like for you to do now is get a highlighter. I'm going to use yellow and blue. So with your first color, go ahead and highlight what u is, x squared plus 1, right? And then come over here, and anywhere you see an x squared plus 1, we're going to highlight that with that same color. All right, now switch colors. I'm going to use blue now, and now let's highlight what du is. So we want that 2x dx. And I'm going to highlight it inside the integral also. Okay. All right, now I'm going to go ahead and rewrite my original integral in terms of u. All right, so I don't want x's anymore. Now I'm going to have u's, and hopefully this will be a much simpler expression. So I still have the integral. Next, I run into some yellow, which I see is u. Right, that yellow stuff we let be u. Next is the square, so I still need that. That didn't go anywhere. And the rest of the stuff is all blue, so that should be du. And remember, du always has to come at the end, so you always need to put that at the end after your integrand. All right, so now recall what this means. This integral symbol combined with du means find all antiderivatives of u squared. So in this case, we would get u cubed over 3 plus c. However, our original problem actually asked us to find all antiderivatives of all this stuff, the quantity x squared plus 1 squared times 2x. Well, that's not a problem now. Now we can just go back and substitute what u was. So u was the quantity x squared plus 1 and I want to cube that over 3 plus c. And that is my final answer. Now, if I wanted to check it, what could I do? Right, if I wanted to check it, I could take the derivative of my answer and see if I do indeed get x squared plus 1 quantity squared times 2x. Maybe you can do that mentally, right? For this guy, we would need the chain rule if I wanted to differentiate that. So the 3 would fly over and would cancel out with this 3. Hold the baby, so we have x squared plus 1, and now my new power would be 2, so that takes care of all of this part. Then times the derivative of the baby would be 2x, and that takes care of that. Then the derivative of a constant is 0, so it does indeed work. And it's a good idea just to remember that you can always go back and check by differentiating. All right, let's try another example. Let's try this. I have the integral of the quantity 4x cubed plus x all raised to the 5th times 12x squared plus 1 dx. Okay, remember this means find all antiderivatives of all of this stuff, the stuff between the integral and the differential. Now, again, somewhat complicated. Let's make this an easier expression, just like we did up here. So let's do a u substitution. What would be a good choice for u? A good choice for u would be 4x cubed plus x. Right, because its derivative is right here, right? So du will be 12x squared plus 1 dx. All right, go ahead and get out your highlighters. So first let's highlight what u is, 4x cubed plus x, which occurs right here. And then change colors and find the remaining part of your integrand, which is 12x squared plus 1 dx. I'm going to highlight that out here also. Okay, so now we are going to rewrite this integral in terms of u, and it should look much simpler. So I still have the integral symbol. Okay, then I run into some yellow, which is equivalent to u. Right, then I have the power of 5 still. And then I have, the rest is just blue, which is equivalent to du. Ooh. All right, so remember, this means find all antiderivatives of u to the 5th. All right, so that would be u to the 6th over 6 plus c. And my final step is going to be to substitute u back in, right? So u was equivalent to 4x cubed plus x. And I want to raise that all to the 6th over 6 plus c. And that is my final answer. And how can we check it? You could check by differentiating your final answer and seeing if you do indeed get back to this stuff. All right. Okay, let's try a few more examples together. How about this guy? Let's do some with trig. If you want, let's go ahead and do this. All right, so I have the integral of tangent cubed x times secant squared x. And don't forget, when we have those powers, that just means tangent x, the whole thing cubed, and secant of x, the whole thing cubed. Okay, well, what do you think we should let u be in this case? A good choice for u is going to be tangent of x Because what is the derivative of tangent of x? Secant squared x, right? Which is part of our integrand. So du is equal to secant squared x dx. All right, go ahead and get out your highlighters, and let's highlight out here. U is tangent of x, so I'm going to let tangent of x, I'm going to go ahead and highlight that in yellow. I do need to miss the cube though, right? Because only tangent of x is u, not the cubed. All right, then du is secant squared x dx, so I can go ahead and highlight all of that in blue. Okay. All right, now let's go ahead and rewrite this integral in terms of u. So the integral stays, then I run into some yellow, which I see is equivalent to u. Okay, then I have the cubed. And the rest is blue, which is equivalent to du. All right, now this here means find all antiderivatives of u cubed. So that's going to be u to the 4th over 4 plus c. And then our last step should be to substitute back in. So u is tangent of x. So I have tangent of x, the whole thing to the 4th over 4 plus c. And how you'll typically see this written is like this, right? Just keep in mind they mean the same thing. Just a little bit less cumbersome, a little bit less to write, but either one is correct. All right, and if we wanted to check, of course, we could take the derivative of this and see if we do come back to tangent cubed x times secant squared x. Okay. How about this trig one? I have the integral of cosine of x over sine of x dx. Now in this case, we want u to actually be sine of x, and it's not because I don't want to deal with the negative when I differentiate cosine of x, because remember, negatives I can deal with. Those are coefficients, they're not bothersome. But we never want du in the denominator. All right, du needs to be the period at the end of the sentence, always has to be being multiplied, okay, not divided. So we need u to be sine of x so that when I differentiate and when I get du, du will be the top piece here. All right, you never want du to be the denominator. Okay, so the derivative of sine of x is cosine x. So du is going to be cosine x dx. Okay, go ahead and grab your highlighters. So I'm going to highlight out u, which is sine of x. And then my second piece is cosine x dx. That's going to be my du. All right, so now let's go ahead and rewrite this integral in terms of u. So I still have the integral. Now on top I actually have blue, which is du, right? And on bottom I have u. So you can rewrite this as du over u, or if you prefer, 1 over u du. Either way. All right, so now I need to find all antiderivatives of 1 over u. And what is that? That's one of our special ones, you remember? This is natural log of the absolute value of u plus c. All right, substituting what u is, we get natural log of the absolute value of sine of x plus c. And that is our final answer. Okay, if you want to check, then you need to take the derivative of the stuff we boxed. And notice here you would need chain rule again to differentiate. All right, so you would differentiate the outside, which would be 1 over sine of x, times the derivative of the inside, which would be cosine of x. So you get cosine over sine. Okay. I'll do a couple more examples if you need them. If you feel good to go, then you're welcome to stop the video and start your homework. All right, let's try 2 more here. So let's find the indefinite integral, aka the antiderivative here. All right, so in this case, I am going to let u be, what do we think? I want u to be x squared, right? Then du will be 2x dx. Now the trouble with that is that I don't have a 2x dx, but I do have a 4x dx. So if I multiply both sides by 2, then I get the piece that I want. Right? All right. So notice that I want 4x dx, and right now my 4x is over here, not next to my dx. So while you're starting out, if you find it helpful to rewrite this as e to the x squared times 4x dx, you sure can. That might be helpful so that your du piece is all together. Right? Okay, so let's get out our highlighters. I'm going to highlight u, which is x squared. So just that part there, right? Not the e. Okay, and then 2 du is 4x dx. So all of this stuff is going to become 2 du. All right, so let's go ahead and rewrite that integral. So I have the integral symbol. Next comes e. Then I hit some yellow, which is, we're substituting with u. And then I have my blue, which is actually 2 du. So what I'd like for you to do is put your coefficients out in front. And then remember, du always has to come last. That's why it's sometimes helpful to rewrite like we did here. Okay, so the 2 is going to come along for the ride. Remember, coefficients are not bothersome. And then this part here means find all antiderivatives of e to the u. So that would be e to the u plus c. And as a final step, we're going to replace u with x squared. So 2 e to the x squared plus, and 2 times a constant is still a constant, so you can have it as 2c or just c, that's fine. Standard notation to just leave it as a plus c. Okay, and again, if we wanted to check, we could derive our answer and see if we got back to 4x times e to the x squared. All right, last one here. I have the integral of sine of 3x times cosine of 3x dx. All right, in this case, what do you think we should let u be? All right, we can let u be either sine of 3x or cosine of 3x. Okay, it's not going to matter because they're both in the numerator. Either way, we're going to get one or the other. We may have an extra negative, but that's just a coefficient, not bothersome. But to spare that that negative, to not have to deal with it, probably the simplest u we could use would be sine of 3x. All right, so again, if you chose cosine of 3x, that's fine, it'll work out also. So if we let u be sine of 3x, then du is going to be cosine of 3x dx. And I'm also missing a what? Hopefully you said a 3, right? Chain rule, so differentiate the mom, which would be cosine, hold the baby, 3x. And we also need to differentiate the baby, which is 3. Okay, now I have cosine of 3x dx and not this 3 again, not bothersome. I can just go ahead and multiply both sides by a third. To get the piece that I need, right? Okay, go ahead and get your highlighters. We're going to highlight u, which is sine of 3x. And then we're going to highlight the 1/3 du portion. So this portion is equivalent to 1/3 du. All right, let's rewrite. We now have the integral. Now I run into some yellow, which is u. Then I run into some blue, which is 1/3 du. Remember, let's put the coefficients out in the front here. They just come along for the ride. Du, your differential must always be last. Right? Your period always has to come at the end of the sentence. All right, so this means 1/3 times all the antiderivatives of u. Okay, so we have 1/3, which comes along for the ride, and then all the antiderivatives of u would be u squared over 2 plus c. Okay, let's go ahead and substitute sine of 3x for u. I'm going to go ahead and write the fraction here as 1/6. Right, 1/3 times a half. U is sine of 3x. And we want to square that. And then 1/3 times a constant is still a constant, so I can just leave that as plus c. And that's your final answer. Okay, just a little note here. For a couple more examples, you may want to see examples 4 and 5 on page 300. I believe at least question 67 in your homework deals with this type of example. I call it a double substitution. So I would recommend looking at those examples before attempting those last few ones on your homework. All right, guys. Good luck with U substitution, and I will see you next time.